Good day, ladies and gentlemen. Today we will be doing analytical geometry. So we will be discussing the concept dealt with in grade 11. So we'll start with the average gradient. The average gradient passing through points A and B, meaning 2 points A and B, is MAB, YB minus YA over XB minus XA. This is the formula that we're gonna use to calculate the gradient between the 2 points. And the distance formula, the distance between any 2 points A and B is given by AB, the square root of YB minus YA all squared plus XB minus XA all squared. Okay, all these under the square root. So that will give us the length of what? Of AB. Now AB can also be written in this form: AB squared equals to YB minus YA all squared plus XB minus XA all squared. Okay, but if you want AB, we all know that we're gonna introduce square root on both sides. Square root will cancel that square. We're gonna be left with something like this. Okay, the midpoint formula. The coordinates of the midpoint of any line segment AB are XA plus XB divided by 2, YA plus YB divided by 2. And we also have the angle of inclination. Now the angle of inclination is often denoted as what? As theta. Okay, the gradient of a line is equal to the tangent of the angle of inclination. That means the gradient M is equal to what? Tan theta is equal to the tangent of the angle of inclination, that is tan theta. Okay, but since we know M can be given by y2 minus y1 and x2 minus x1, and the angle theta, it is the angle between 0 degrees and 180 degrees. Okay, so we can find the values of the theta will always be between 0 degrees and 180 degrees. So since we'll be dealing with straight lines here, now we can have a line that has a positive gradient where m is greater than 0. So that will mean our theta is going to be an acute angle in this case. So it means theta is going to be less than 90 degrees in this case. But once we have a straight line with a negative gradient where m is less than 0, so we are going to have an angle of theta that is greater than 90 degrees. So theta here is going to be greater than 90 degrees. Okay, now how do we get the equation of a straight line? The equation of a straight line, we can use two formulas. The first one can be y equals to mx plus c, where m is the gradient. Okay, or alternative, we can use y minus y1, which equals to m, which is the gradient, into x minus x1. So in this case, y1 and x1 will be the point on graph. Here we're gonna use the point on graph on y and x to solve for c once we have the gradient, and then we can substitute everything back except for y and x. But in this case, we just substitute the point on graph, the gradient, and the point on graph, and we work out whatever that we will be having there, and then we leave y as the subject of the formula. Now, equations of a horizontal line. Okay, so that will be y equals to k, where k is just a constant. And equations of a vertical line, we use only x. x equals to k, where k is just a constant. For what? For vertical lines. And for horizontal lines, just a constant. No y equals to 2x. No, that one is for an angle, for lines that have a gradient like this one. But if it is a horizontal line, it does not have a gradient, so y is just a constant, is equals to a constant k. And if it is vertical, x is just equals to k, which is a constant. A constant, it can be a number like 3, 4, 5, or 1, okay, or even 0. Now the gradients of perpendicular and parallel lines. Okay, we know that the product of the gradients of perpendicular lines, the product, meaning here we are multiplying the product of the gradients of perpendicular lines, is equal to -1. So that will be m1 multiplied by m2 is equal to -1. That's if we have what? That's if we have two lines. For example, we can have a line here and another line there. Okay, now this is going to be line 1, this one is going to be line 2, this one. Okay, so if we get a gradient for this line 1 and we have a gradient for this line 2, if we multiply the two gradients, our answer is going to be equal to -1. So we're gonna be making use of this relationship to get the gradient of the second line. For example, we can have the gradient of this line, and the gradient of this line can be unknown. Okay, so we can use this relationship to find the gradient of line 2, since we know this one. So we come here, we just substitute the gradient here, m1, m2, we leave it like that. We say this is equal to -1. Okay, we can only use this relationship provided that the two lines are perpendicular to each other, and then we can solve for this gradient m2. Okay, now the gradients of parallel lines are equal, m1 equals to m2. So if we can have two parallel lines, straight lines like this, okay, this is line 1, this is line 2. So if the two lines are parallel, then we know that the gradient of the two lines is the same. We can have m1, maybe let's say m1 is equal to 2. That will mean m2 is equal to what? Is equal to 2, simply because the two lines are parallel. Okay, so let us do the examples to cover all that we just discussed now. Let us now do example 1. Let us do example 1. So what do we have? Example 1, say consider the following graph and answer the questions that follow. Now we've got 3 points there, A, B, C, B with the coordinates 5:6, A with the coordinates 3:1, C we don't have the coordinates. Now here we are asked to calculate the length of AB. Calculate the length of AB. Okay, now I'm going to write my solutions on this side. Okay, I'm gonna say solutions. Okay, we know that the formula for calculating the length is what is gonna be AB is equal to the square root of we have it here, okay, that will be what? That will be YB minus YA squared plus XB minus XA all squared, just like that. Now what are the coordinates for B? Now for B we have YB is what? YB is 5 5 minus 1 squared plus xb yb no yb it's 6 here, it's 6 y not x, y is 6, it's 6 there, we have 6 there, 6 minus 1 and this is gonna be 5 minus 3 all squared. So we are going to have 6 minus 1 is 5 squared plus 5 minus 3 is 2 squared. So we can punch this in our calculator. We can have the square root of 5 squared plus 2 squared. We're going to get the square root of 29. Square root of 29 is what? It's 5,39 units. So this is going to be the length of what? This is going to be the length of AB. Okay. Now, second question. Determine the coordinates of C, the midpoint of AB. So C is the midpoint of what? Is the midpoint of AB. Okay. Now, how do we do that? Now we're covering B now. So we're gonna say the midpoint, this is for what? For C, is gonna be equal to what? XA plus XB divided by 2 is to YA plus YB all divided by 2. Now, what is XA? XA is 3. So we're going to have 3 plus XB is what? Is 5. 3 plus 5 divided by 2 is to YA, that will be 1 plus YB, which is 6 divided by 2. This is going to be 8 divided by 2, and this is going to be 7 over 2. This is going to give us 4 is to 7 over 2. So this will be the coordinate of what? The coordinate of C. This will be the coordinate of C, just like that. So the next question, it's number 3. So here I used A, so this is supposed to be number 1, number 2. So now number 3, calculate the gradient of the line AB. Now calculate the gradient of the line AB. Now that will be what? For line AB, we're gonna see number 3, MAB is equal to YB minus YA divided by XB minus XA. This is going to give us that is B is 6 minus 1 over 5 minus 3. So we're going to have 6 minus 1 there, it's 5. 5 minus 3 is 2. 5 minus 3 is 2. So this is going to be the gradient of what? The gradient of the line AB. Okay. So what is the next question? Next question is calculate the value of theta. So we can see theta there. So theta is what? Is the angle of what? Is the angle of inclination. Is the angle of inclination. So what do we know about the angle of inclination? It was discussed here that tan theta is equal to what? Is equal to m. It's equal to m, like we did there. Okay. but we also know the gradient of what? The gradient of this of the line AB. You know the gradient of the line AB. So how do we do that one? Say number 4. So we're gonna say tan theta is going to be equal to the gradient of the line AB. Okay, so that will mean tan theta is equal to 5 over 2. Okay, so this is going to be theta is equal to arc tan 5 over 2. This is going to be equal to shift arc tan 5 over 2, 68,2. That will be 68,20 degrees. This is going to be what? This is going to be the value of the angle theta. Okay, because it has a positive gradient, then theta is going to be less than 90 degrees. Okay, now next question, then we have number 5. Determine the equation of the line AB. Determine the equation of the line AB. Now with number 5, we have the gradient there. Number 5, the gradient of AB is equal to 5 over 2. We also have 2 points there. We can choose any. So I'm going to take this one, point A, because this point is on the line, this line of AB. So point A, the coordinates of point A is 3:1. 3:1. So I'm going to use what to call two options, the two formulas that we have. Okay, so the first one is going to be y is equal to mx plus c. With this one, we just substitute the point where we see y and x, and the gradient we solve for c. So we're gonna say 1 is equal to m is 5 over 2, and x is what? X is 3, c plus c. So this means what? 1 is going to be equal to 15 over 2 plus c. We transpose this, 1 minus 15 over 2 is equal to c. And then you see 1 minus 15 over 2, negative 13 over 2. We're gonna have negative 13 over 2 on this side, which is equal to c. Okay, so now our equation, we substitute everything back except for y and x. So that will be y is equal to 5 over 2x minus 13 over 2. Now this will be the equation of the line AB. Okay, now the second method is y minus y1, which is equal to mx minus x1. So y1 and x1 is the point on graph. So we're gonna see y minus, what is y1 is 1 is equal to 5 over 2, x1 is the point, which is 3 minus 3. So this is going to be y minus 1 is equal to 5 over 2x and then this is going to be negative 15 over 2. Then I'm transposing 1 to the other side. Y is going to be equal to 5 over 2 x minus 15 over 2 plus 1. So y is going to be equal to 5 over 2x, and then we're going to have negative 15 over 2, negative 15 over 2 plus 1. That will be negative 13 over 2, which is the same as this one. Okay, so you can choose if you're gonna be using this method or this method. Okay, that was for number 5. So for number 6, determine. For number 6, what we have: determine the equation of a line, of a horizontal line passing through point A. Okay, so now they are saying we've got a horizontal line that is passing through point A. Line, that line is passing through point A there, and it is horizontal. So we can see that, okay, the y value on point A is what? Is 1. Okay, so it means this line is passing through 1. So that should be easy. We're gonna say for number 6, that will be what? That will be y is equal to 1, which is what? Which is a constant. Okay. Number 7, determine the equation of a vertical line passing through point A. So the vertical line passing through point A will be passing here, like this. That will be the line passing through point A. That will be the line. Okay. So the equation of that line is going to be, and the x value through point A is 3. So that will be for number 7. For number 7, we're just gonna say, okay, this is x is equal to, this is x is equal to 3, which is a constant. Are we together, good people? Hope we are. And let us now do example 2. Example 2. Now with example 2, what do we have? Example 2, consider the following linear graphs and answer the questions that follows. Now the first question here that we have is calculate, or we can see that we've got what? 3 points, A, B, C. Okay, and then we've got 2 parallel lines, and then we've got an angle of inclination there, beta. You can see that. Okay, so the question: calculate the gradient of a line passing through A and B. Okay, so that should be simple stuff for us. That will be for number 1. We're gonna say, okay, MAB gonna be YA minus YB over XA minus XB. This is going to be equal to XA is what? The YA is 4, so we're gonna have 4 minus 0 over XA is 0, 0 minus 2, 0 minus 2, so that is going to be equal to 4 over negative 2. That is going to be equal to negative 2. That is going to be our our gradient for what? For this line AB. And then the next question is determine the equation of a line parallel to AB and passing through point C. Now we are asked to determine the equation of this line. But what do we know? And then we know that for us to determine the equation of this line, we need to have a gradient and a point. So we are covered with the point because we have the coordinates of point C. But what about the gradient? Now we remember that, so for parallel lines, we know that for parallel lines, the gradient of the parallel lines are the same. So we're gonna say number 2, let's call it MC because we only have C. That will be MC is going to equal to MAB. Okay, so that means the gradient of MC is also going to be equal to negative 2. What do we have? We have also the point what? Point C. Okay, point C, what are the coordinates for point C? That will be 0 is to negative 2. 0 is to negative 2. Okay, so we can just say y minus y1 is equal to mx minus x1, and then we say y minus y1 is what? Is the point, that will be into minus 2 is equal to negative 2, which is the gradient. X, we'll leave it like that, x minus 0, just like that. So we're gonna have y plus 2 is equal to negative 2x. Then we transpose this, y is gonna be equal to negative 2x minus 2. This will be the equation of this line that is parallel to what? That is parallel to AB. Okay, good. Now the next question, calculate the size of beta. Beta is that one. Okay, so for the angle of inclination, we know that, okay, and number 3, we know that, okay, tan of beta is going to be equal to MC is equal to the gradient of this line, this angle. Okay, so but the gradient is now negative, so we're gonna substitute it as negative. So we're gonna say tan beta is gonna be equal to negative 2, and beta is going to be tan negative 2. So we are going to get what? We are going to get a negative angle there. So that will be tan negative 2. No, shift tan negative 2. That is going to give us negative 63,43 degrees. So what does this mean? So this negative, now this negative 63,43 is this angle on this side, because negative, we know that if we have negative angles, we move clockwise. Okay, so for positive angles, we move anti-clockwise. So this is the angle we are moving clockwise. This is negative what? Negative 63,43, but we are looking for this one. But we know that this whole angle here is 180, so we are just going to subtract this angle from 180 and we are going to get beta. Okay, instead of beta we could have used theta. instead. Set theta, and then we say this one is theta, and this one is theta, and this one is theta. Now beta, that angle, our angle now beta, our angle, this one, our angle beta now is going to be equal to 180 degrees minus 63.43 degrees. The answer is going to be 180 minus 63.43. The answer is 116.57 degrees. That will be the size of what? The size of beta. Okay, simply because we also discussed that if we got a negative gradient there, our angle theta is going to be greater than 90 degrees. So our beta, which is 116.57 degrees, is greater than 90 degrees. Okay, good. Now we have another question. Another question that will be: determine the equation of a line perpendicular to line AB and passing through point 3 and 4. Passing through point 3 and 4. Now, that line that is perpendicular to AB is passing through the points 3 and 4. Okay, so it means if you've got 2 here, you're gonna have 3 somewhere there, and 4 is here. So we're having a line perpendicular to AB passing through this. So it means this line, that line will be passing like this. This is the line that we will be having. Okay, and then it will form what? It will form 90 degrees with what? With the line AB, because we are told that it is perpendicular to line AB. Okay, so how do we solve that one then? Then we're gonna say, okay, you know that let's just call it M1. That will be M1. If you multiply M1 with what? With MAB, we know that we should get -1. But we do not know the gradient of this. What we only know is the point there, which is 3 and 4. So we are gonna get this, the current of that line, using this relationship. So that will be M1 multiplied by MAB. We got MAB here as -2. So we substitute what? We substitute -2 there, which equals to -1. Okay, so that will be, this will be -2. M1 is equal to -1. We divide both sides by -2. By -2, this cancels that. So M1 is going to be equal to, negative cancels negative, 1 over 2. 1 over 2. Now we have what? We have the gradient. So we can simply use y is equal to, let me use another equation now, mx plus c. Okay, we have a point there, is 3 what? 3 and 4. So that will be 4 is equal to 1 over 2. The value of x is 3 plus c, and then this is going to be 4. 4 is equal to 3 over 2 plus c, and then 4 minus 3 over 2 is equal to c, and then 4 minus 3 over 2, that will be 5 over 2. 5 over 2 is equal to C. So the equation is going to be y is equal to 1 over 2x plus 5 over 2. This is going to be the equation of a line, that line that is perpendicular to AB and is passing through the point 3 and 4. Okay, so let us also check our last example 3. Now, example 3, consider the following 3 points on the Cartesian plane. We've got AB, ABC. A is negative 2 and 1, B is 1 is to 2, and C is 4 is to 5. And they are saying now, prove that the 3 points are collinear. What does this mean? The 3 points are collinear. So the 3 points are collinear points. You have collinear points if all these points are on the same line. It means all these points are on the same straight line. And how can we prove that? We can only prove that if we can prove that MAB, this one, is equal to MBC, or MAC, okay, it's like that. If we can prove that MAB, this gradient between this point, 2 points, is equal to that, or that is equal to the gradient between these 2 points, or the 2 points, the gradient between the 2 points is equal to the gradient of the 2 points. Okay, so let's keep it simple. We're going to look for the gradient of what? Of the gradient between the 2 points AB and the gradient between the 2 points BC. If the gradient is the same, therefore the points ABC are collinear. So that will be for our solution. Let me use a different color for our solution. We're gonna say MAB is equal to YB minus YA all over XB minus XXA. That will be what do we have for YB? That will be 2 minus 1 over XB. That will be 1 minus into minus 2. So that will be 2 minus 1 is 1 over 1 plus 2. 1 plus 2, that will be 1 plus 2, that is going to be equal to 1 over 3. Now let us do MBC. That will be YC minus YB all over XC minus XB. So we're gonna have YC is 5 minus 2 over XC 4 minus 1. 4 minus 1. So 5 minus 2. 5 minus 2 is what? 5 minus 2 is 3. Wait, YC, that is 5, yeah? 5 minus 2 is 5 minus 2. And then we have 4 minus 1, 4 minus 1. So 5 minus 2 is 3. 4 minus 1 is also 3. is also 3. So 3 over 3 is what? 3 over 3 is 1. Okay. Now I'm seeing something here with this example here. I think we must have made a mistake here. Okay, because here we cannot have a positive 1 here for a, because it's on this side. All the values this side for y are negative. Okay, are negative. This has to be negative, negative, negative 1. So here for y it should have been 2 minus, this is going to be negative 1, 2 minus 1, that will be 2 plus 1. Okay, that will be 2 plus 1, that will become 3. So it's gonna be 3 over 2 plus 1 is 3, then it becomes 3 over 3. 3 over 3 is equal to 1. Yes, no, I fixed that mistake. Sorry for that. But to calculate the gradient, the same as you've been calculating with the previous examples. So we can see that MAB is equal to what? MBC. Therefore the points what? A, comma B and C are collinear. That's how we prove collinear points. I hope you understood, good people. Until we meet on the next lesson, I thank you.